let's take a look at a couple story problems involving supplementary angles, complementary angles, linear pairs, and vertical angles. So first up, I'm reading this and blah blah blah. The most important part of this is the word supplementary or supplement. So I know that supplementary means 180 degrees, and specifically it means that two angles are going to add up to 180. So I'm going to use that to help me write my equation. So back to the words I blah blahed over. They say the measure of one angle is 7 times the measure of its supplement. So in other words, I don't know either angle. Well, since I don't know the first angle, and we're basically doing algebra right here, I'm going to say that that first angle is x, because I don't know what it is. The other angle that says it's 7 times that is, well, 7 times x means 7x. And again, thinking back to this idea of supplementary, what it means is that two angles will add up to 180. So there's my equation that represents this situation. So from there, I'm just going to do some algebra to solve this. 1x plus 7x gives me 8x equal to 180. If I divide this out, I come up with an x value of 22.5 degrees. So there's one of my angles, but notice in the directions they said find the measure of each one. So if one of them is 225, I can find the supplement of that by subtracting. I can do 180 minus 22.5. and get my other angle, that's 157.5 degrees. Some people also figured out they could just take their 22.5 and plug in for x up here. 7 times 22.5 is also 157. So either way you want to do it, there's your two supplementary angles. Alright, let's try one more of these. This time they tell me that two angles form a linear pair. Well, again, there's your key word that's telling you two angles are going to be adding up to 180 degrees, just like supplementary angles. So let's see what they give us in terms of angles this time to finish writing our equation. They say that one angle is 75 degrees less than the other. So once again, I don't know either one. So let's call the first one x. I don't know that angle. The second one, that's 75 less than, I can express that as x minus 75. And I'll put an equal sign there, and there's my equation. So x is one of my angles, x minus 75 is the other one. Since they make a linear pair, they're adding up to 180. So let's combine some like terms. I get 2x. I think at the same time I'm going to add 75 to both sides and just save some time. So I get 2x equals 255. And then if I divide to finish this, I get one of my missing angles to be 127.5 degrees. And I'm noticing in the directions again they said find the measure of each angle. So if one of them is 127.5, let's find the supplement of that by subtracting from 180. And I get another angle, my second angle, of 52.5 degrees. Once again, some people figured out that another way to do this would be to find your x value, plug it back in up here for the x minus 75. That'll also get you the 55.5 degrees. Alright, and then some of my favorite problems, I call them G-algebra problems because they combine the best of both worlds. We have geometry and algebra combining to make these wonderful problems. So our geometry comes to us because we see that these two angles are a linear pair. Together they make a straight line. So knowing what I know about linear pairs, I know that two angles are going to be adding together to equal 180. That's what a linear pair means. That's what a straight line means, or has as far as degrees. So then for my actual equation, my algebra part of this, I'm going to say 7x minus 3, that's one of my angles. And I'm going to drop the parentheses since there was nothing to distribute. I can just drop them. The other angle is expressed as 12x minus 7, and there's the equation I'm going to have. Again, the 180 comes from the fact that I'm adding up two angles that are supplementary, or I have a linear pair. That number could have been 90 if I was working with a right angle, or it could have been these two angles equal if I was working with vertical angles. So there's really only those three setups. Either add them up to equal 180 like we did in this case, add them up to equal 90 if they're complementary, or put the two angles equal to each other if they're vertical. So now that we have our geometry done, let's go ahead and do our algebra to solve this. So if I combine some like terms, I've got 19x minus 10 equal to 180. I'll go ahead and add 10 to both sides, so 19x is equal to 190, and then divide to get an answer of x equals 10. Before you get too far with this problem, they'll go back to the directions and notice there were two parts. They asked us to find the value of the variables, which we did. There's only x, in this case it was 10, but they also say find the measures of each of the angles in the problem. So now that I know x is 10, though, finding the angles won't be too bad, and this is actually a really good way to check your answer. So take your x, which is 10, and plug it back into the original equation. So 12 times 10 minus 70, or 7, gets me 113 degrees for this angle right here. Plug x in over here as well. So 7 times 10 is 70. Subtract that 3 gets you 67 degrees. If I check this problem, I can add up 67 and 113, and they do indeed add up to 180. Okay, and then our very last problem. One thing that I noticed right away is I have vertical angles right there, angles that are across from each other. And I remember that vertical angles are equal to each other, so I could try to write 2y equals 7x. And that's a true statement. 2y does equal 7x because those are vertical angles, but you'll see the problem right away is that I have two variables and I can't do that. So even though this statement is true, it's not very helpful. So I'm not going to be able to use vertical angles, not yet. Instead, let's find where the x's are, because I want to use both the x's together. So they're right here. They're not vertical angles. They're angles that are next to each other. They make a straight line. So just like that previous example, I have, again, this idea of supplementary angles. So I'm going to say 9x plus 20, that's one of the angles. I'm going to add to that the 7x, and I'm ignoring the 2y. It has nothing to do with what I need to do right now. I'm going to put that equal to 180 because they make a straight line. They're a linear pair. So let's go ahead and solve for x and see if that gives us any ideas for what y is going to be. So if I add up like terms again, I've got 16x. I'm going to subtract 20 at the same time from both sides. So 16x would equal 160. If I divide both sides by 10, or by 16, once again I find out that x is equal to 10, which is great, but now remember they still wanted the measures of the angles, so let's plug that back in our equation, or our picture, and see what our angles are and see if that gives us any insight for finding y next. So I'm going to plug in 10 for x, 7 times 10 gets me 70 degrees for this angle right here, and then plug in 10 for x up here, 9 times 10 is 90, add 20 onto that, so there's 110. Again, I can check that by adding those two angles together. 110 plus 70 is 180 like we said it should be. Well, now what I'm going to do, since I know that 7x is really just a 70-degree angle, now I'm going to go ahead and look at vertical angles. Maybe I should use a different color. Let's go with red. So I'm going to look at these, this right here. So again, these two are vertical angles, so they are equal to each other. I can say that 2y is equal to 70. And now I don't have that problem of the two variables to deal with. There's only the y. So if I finish this by dividing both sides, I come up with an answer of y is 35. And since that's not an angle by itself, I'm not going to put a degree symbol on it. If I wanted to check it, go back and plug in 35 for y. 2 times 35 gets me 70 degrees, which we said had to be the case because we have vertical angles that need to be equal to each other.